So the third video on information processing looks at reaction time, and I'm sure you're familiar with this possibly from GCSEP, this phrase, and it's used in many of your sports. So the specification actually needs you to look at three elements: reaction time, movement time and response time, and understand the relationship between those three factors. You need to be able to describe the impact of reaction time on performance. So is it helpful? How does it help? And also explain factors that may affect overall response time to certain sports. So what can make response time faster or slower, whether these are internal or external factors. And then obviously look at, there's a couple of theories that you need to acknowledge in terms of reaction time, so we need to learn those. So what is reaction time, response time and movement time? So at the top here we've got an equation, and obviously you need to learn this. Response time, reaction time, movement time. Now this is the thing that you're probably familiar with, but understand the relationship between the two. Response time equals reaction time times movement time. So what is reaction time? Reaction time actually looks at the time it takes between a stimulus and the initiation of a response. So the initiation of movement. So in this example, the gun goes off for a 100-meter sprint, and the performer begins to start to move out of the blocks. It's not movement, it's the initiation, the start of movement. So reaction time from the stimulus to the initiation of movement. That's reaction time. Then what we have is movement time. So they've now started to move, and they move to the end until the movement ceases. So movement time is obviously the start of movement till the end of movement, leaving the blocks to the finish line. And as you might be able to guess, response time is the complete process. So from the gun till the end of movement. So reaction time plus movement time equals response time. Where students get confused is this here. Reaction time is from the stimulus to the start of movement, not movement to the start of movement. So let's make that really clear. So these are some things that can affect response time or reaction time. Things like age, gender, fatigue, personality. Now some of these aren't really changeable. Age and gender are clearly not, personality is not. These things can't be changed and may affect how quick or how slow you are to react and respond. Fatigue obviously is transient, so you may be more or less fatigued depending on what you're doing. The more fatigued you are, the slower your reaction times. What I'd probably suggest is pause the video, have a look at some of these in more time, take your time, read through each one. So personality, for example, if you are more introverted, you tend to have slower reaction times than if you're more extroverted. Arousal levels, if you are highly aroused, i.e. you are mentally and physiologically ready, you can react and respond quicker than if you are less aroused. And body temperature, you need to be at optimal levels of optimal temperature. So if you are warmer, you'll have quicker reaction time than if you're slow, which actually makes sense. If you're going to do a 100-meter sprint, physically warm up so that your neural pathways and your muscles will transmit impulses faster and react quicker than if you're colder. So a lot of the blue eye sort of circles here represent internal factors. External factors might be to do with things like the intensity or the size of the stimulus. If there's a quiet bang as opposed to a very loud bang, that loud bang is a much larger or more intense stimulus, and that might provoke a quicker reaction time. If you're teaching tennis or catching and you use larger or brighter balls to catch or to pass, that's a larger or brighter or bigger stimulus, and that might help the reaction time of the subject. The probability that things are going to occur, so the more you're expecting that stimulus, the more likely that stimulus is to happen. You can react perhaps faster. If, for example, a bowling machine is coming to you at a very set pace and you know that there's a chance that it's going to happen at exactly the same time, time interval, you can predict it, and that will help your reaction time. That's linking with anticipation. If there are cues that you recognise, so if you know that on your marks instruction, on your marks set go, the on your marks set is a warning that the go is on its way, the go is going to come. So again, you can anticipate that, or the arm goes up. Or if you see somebody looking like they're going to pass, you recognise their body position, that's a warning sign that they're going to pass. So there's lots of internal and external factors that can affect reaction time and therefore response time. Now we have different sort of theories applied to reaction time. We have this simple and choice reaction time. Now, simple reaction time refers to things where there's no real decision making. There's a stimulus, and then there's a simple reaction to that stimulus. The response that you're going to do is predetermined. For example, when the klaxon goes at the start of a race in swimming, you don't think about what you're going to do. You don't think, am I going to do a cartwheel now? You literally have one set reaction. You are going to dive in as quickly as you can. So that is a simple reaction, the stimulus and a predetermined reaction where no decision making takes place. Choice reaction time, however, as it suggests, involves some decision making, some choices. So there's a stimulus, there's a player, or there's a situation, or there's a player shouting for the ball across the way on your team. But before you pass to that person, you might need to make a decision. Do I run? Do I pass? Do I pass to my other teammate? Do I pass to the teammate that's shouting? Now, given that there's more decisions to make or more processing that's happening, it's likely that the time it takes to react to this situation will be slower. So simple reaction time will tend to be quicker than choice reaction time, where you've got to actually have some processing. This can be represented in sort of graph form by what we call Hicks' law. Now, the time taken to respond increases if there's more stimuli, there's more choices, there's more options. So where the simple reaction time, so a situation happens and there's really only one action to happen, the time you take to respond will be very low. You'll react very quickly. If there's more decisions, like in an open skill situation, an open environment where you've got to process information, make decisions, the more choices there are, the slower you are to respond, the slower your reaction time. And that can obviously be a problem. So Hicks' law refers to the fact that the more choice there is, the slower your reaction time, the slower you are to respond. So how can we improve response or reaction time? Because often in sport we want to minimise this. The quicker we can do something, the quicker we can make a decision, the better for our performance, if it's the right decision. Obviously high levels of concentration matter. Being warmed up can help, because we've said increased temperature can help reaction time. Controlling our arousal to have an optimal level, so not being too aroused that we react too quickly and maybe make the wrong decision, or having too low arousal that we are slow. Having mentally rehearsed responses, so knowing what to do because we've practiced in our head what to do, can help. The fitter we are, the better we'll respond or react. Experienced people will be able to make decisions and process information much better than cognitive learners. So being autonomous, you'll know what to do more quickly. Cue detection. Now this involves selecting the appropriate cues and attending to the appropriate cues. So let's take the example of a batsman in cricket. If you see the bowler approaching and they take on a certain body position in preparation for their bowling, you will detect that, and you might be able to then anticipate what type of bowl they're going to do, and you might therefore react better to it. So actually anticipation is very central in how we can improve reaction time and response time. But there are two types of anticipation. One is spatial anticipation, so the space of where things are going to happen. Again, a good example is a bowler. if you can anticipate the length or the pitch or the direction or the angle of the bowl coming at you, you can play a shot better. You will anticipate the correct reaction and response time will be reduced. Temporal anticipation revolves to the timing of the action, of the stimulus. So on your marks, set, go. That process, that the timing of that speech is quite predetermined, and within reason you can anticipate when the go command is going to go, or when the gun is going to go off, because on your marks, set, go is often said at the same rate. That would be temporal anticipation. Or, again, as I said, anticipating the timing of the ball coming towards you, at what point the ball is going to be released, anticipating the speed of the ball coming towards you, and then at what point to react and strike, make your body position to strike the ball. So we've got two types of anticipation: spatial, the space, the where of things are going to happen, and temporal, the timing. So maybe that's the way you remember. Temporal is timing, spatial is obviously space related, where. This should say when, that's a typo. Lastly, we've got this thing which I'm sure many of you have done in your sports but may not understand the terminology of what it's labelled as. So this player in white here is faking passing the ball in that direction, but actually is probably going to keep hold of it and travel towards basket to try to make a shot. So this fake shot, something I'm sure all of you have done in one shape or form. This is called the psychological refractory period, but it basically is a fake, a dummy. What happens is the player would provide a stimulus, i.e. they would make the gesture of passing in one direction. Now, in response to that original stimulus, the defender would put into process the body movement to move in the direction of where they think that pass is going. So they'd respond or begin to respond to that first stimulus. However, the person with the ball might then not make that pass and would carry on to basket, which is the second stimulus. They're driving to basket now. Now, however, before the defender can react to that second stimulus, they've got to kind of go through the motions of finishing off, reacting to that first stimulus. So there's a period of overlap here where they're responding to the first stimulus, but the second stimulus is already happening. And this is called the refractory period. During this period, the defender can do nothing to change their mind. They have to kind of follow through their original response, their original reaction. And in that time, the attacker kind of gets ahead. They're able to drive to basket whilst the defender is consumed by this first reaction. And it's only now, later on, that this defender can almost change their response and try to go to basket to stop the shot. So this refractory period gets the attacker an advantage, gets the attacker a period when their defender can't respond to them. So this is called the psychological refractory period. The first stimulus must be responded to by the defender. Even though the second stimulus happens, there's a delay before the defender can react to the second stimulus. That's called the refractory period, the fake move. So the fake, the real move, the fake, the responder has to respond to the fake before they're able to respond to the real move. And this is the refractory period, the delay in those two responses. And this is the advantage that the attacker has over the defender. So these are the kinds of questions you might have. Why is it important to develop quick reactions in performing skills? What factor could affect response time? So that would ask you to talk about the I's and the E's, the internal and the external factors. Quick response times are a feature of many things. Define reaction time, movement time and response time. So that equation, response time equals reaction times time, movement time. Give some definitions and give some examples.